Okay, so today I want to talk about section 3.3, how derivatives affect the shape of a graph. Just like outline, I want to talk about increasing, decreasing test, the first derivative test, the concavity test, inflection point, the second derivative test. I want to talk about these whole kind of things. So first one, increasing and decreasing. This is the definition. Let the I be a given interval. The function f is increasing on the interval I. If f of x2 is greater than f of x1, whenever x2 is greater than x1 on I. The function f is decreasing on interval I. If f of x2 is greater than less than f of x1 whenever x2 is greater than x1. So this is like very clear. You can draw the graph here. Graph is like x1. You can choose 2 points, like x1, x2. The x2 is greater than x1. This is assumption. You can think about corresponding function value. This value is f of x1. This one is f of x2. F of x2 is greater than f of x1. Graph is increasing. Decreasing, similar. Graph is like this. You can choose 2 points. This one is x1, x2. Here we have this assumption, this one. We can compare corresponding function value. You plug x1, this is like f of x1. So this one is f of x2. What's that? F of x1 is greater than f of x2. The graph is decreasing. It's like algebraic definition. So graphs like this. The increasing from A to B is increasing. B to C decreasing. C to D increasing again. So like this. So we think about derivative. So what happens? Just like increasing things, you can choose 1 point, draw tangent line. So like this. This is point x. What is f prime of x? F prime of x is the slope of tangent line. The slope of tangent line is increasing. The slope is positive number. We have one good result. The decreasing from B to C, what happens? F prime of x is less than 0. What's that? You can choose 1 point. Here, decreasing one. This is like x. You can draw tangent line. This is tangent line. What's the slope? The slope of tangent line is less than 0. So how can you find the slope of tangent line? F prime of x. F prime of x is less than 0. So we have this kind of result. So we have increasing, decreasing test. So what's that? The I is a given interval. F prime of x is positive. The function is increasing. The f prime of x is less than 0. F is decreasing on interval I. So we call increasing, decreasing test. The question, how to check if f has local maximum or local minimum? This is one example. We have local maximum in here. What's that? What is f prime of c? Do you know what's f prime of c? Could you write your answer on the chatting board, please? What is f prime of c? F prime of c is, yes, we have horizontal tangent line. Slope is, yes, 0. What is c? The c is critical number. The one more, we have local maximum at C. What happens f prime of x, the x value is less than c. This one is the slope is positive, right? You can choose x value here. The slope tangent line is positive. This is positive. Was it like x is greater than c? The slope is negative. So what does it mean? The f prime of x is like increasing and decreasing. We have local maximum. How can check local maximum? F prime of c equal to 0, like critical number. The one more, sign of f prime is changed from positive to negative. So we have local maximum. So one more example is graphs like this. This one, this is C. Is C. What is f prime of C? So could you write your answer? What is f prime of C in this case? Do you know what is f prime of C? We have a corner. Yup, this is a corner. Derivative does not exist. What's that? The C is critical number. The critical number. So let me see. What is f prime of x? X is less than c. You can choose this point. You can draw tangent line. The slope tangent line is positive. You can choose x values here. The slope of tangent line is negative. The sign of f prime of x is changed from positive to negative. One more, the c is critical number. We have local maximum. It's like a key for finding the local maximum. The local minimum, the similar. The c here, take a derivative f prime of c equal to 0. So what happens? F prime of x. You can choose point x here. X is less than c. This point. The tangent line has negative slope. The negative slope. You can choose point x is here. X is greater than c. You choose point. The slope tangent line is positive, right? So f prime of x changed from negative to positive. The c is a critical number. We have local minimum, the critical number. Local minimum. The next, like this. So we don't have a local maximum, local minimum. The c is here. So what happens? F prime of c equal to 0, like a critical number. The c is like a critical number, but what happens f prime of x? X is less than c. Choose this point, draw a tangent line, slope is positive. You choose point, x is greater than c. You can choose this point, slope is also positive. What does it mean? Sign of f prime of x is not changed. Positive, positive, but critical number, so we don't have a local maximum, we don't have a local minimum. So similar, f prime of c equal to 0. You can choose prime of x, point x is here, this point, slope is negative, f prime is like negative. You can choose x values here. The slope tangent line is also negative. Sign doesn't change. The c is a critical number, but we don't have a local maximum, local minimum. That's good. So what's like idea? So from these examples, we have the first derivative test. What's like a first derivative test? The method for finding local maximum and local minimum. So we have the assumption. The c is a critical number of a continuous function f. This is an important thing. Function f is what? Continuous function. What's a critical number? So we have either f prime of c equal to 0 or f prime of c does not exist, right? Does not exist. So one more, the c is in the domain. in the domain that we call critical number, the critical number. So f prime changed from positive to negative SC. F has a local maximum SC. F prime changes from negative to positive SC, then F has local minimum. If F prime is positive to the left and the right, sign doesn't change. Or negative to the left and the right of C, the sign doesn't change. So we don't have a local maximum, we don't have a local minimum. So we have this idea. The C is critical number. You can define F prime. So you can choose a point here. The left-hand side has positive. The right-hand side has F prime is like negative. What's the graph of F? Graph of F is increasing and decreasing. Graph is increasing, decreasing. We have local maximum. Like this. One more here. See, F prime is like negative to positive. What's it like graph of F? Decreasing and increasing. What does it mean? Graph is decreasing, increasing. We have local minimum. F of C is local minimum. This one. The one more. See here. What happens if prime? Positive, positive. Or negative, negative. Sign doesn't change. So what's F of C? The not a local maximum, not a local minimum, nothing, nothing, right? It's like a whole idea for finding local maximum, local minimum. So we call first derivative testing. Like this. Example, suppose that f prime of x equaled x plus 3 cube, x minus 1 times x minus 5 square. Find the intervals on each f is increasing or decreasing, and find the local maximum and local minimum. How can you solve these kind of things? We have these steps. Step 1. So you can just solve either one. F prime of x equal to 0 or f prime of x does not exist, like a critical number. You can solve here. F prime of x equal to 0, what's that? F prime of x is given here. So we have x plus 3 cube, x minus 1 times x minus 5 equal to 0. The second one, this is like well defined for any real number. We don't have it. We don't have it. So here, x is the negative 3, 1, and 5. We have these three numbers. Step 2, you can check the sign. I can do that. Draw real line. You can plot the negative 3, 1, 5. You can plot this point. You can check f prime of x is positive or negative. Was it like this one? We have this interval, negative infinity to negative 3, the first interval. Second interval is negative 3 and 1. The third interval is 1 to 5. 5 to infinity. So how can you check f prime of x is positive or negative on the left interval? You can choose any test point here. So I can use any test point here. You can choose test point, this one. The test point is less than negative 3. I can choose minus 4. Minus 4, you plug into x. So my question is, f prime of x is positive or negative? Could you write your answer on the chatting board? So what's that? You can plug the negative 4 into x here, negative 4. What's that? The f prime of x is positive or negative. Could you run your answer on the chatting board? You can the positive or negative. What do you think? So could you run your answer? You can plug -4 into here, here, here. What's the whole thing? F prime of x is positive or negative? What do you think? The negative is right. I can check. The -4 plus 3 is -1. -1 cube is, yes, negative. The -4 into here, the -4 -1 is also negative. Third one, the -4 -5 is -9, but power is even. The -9 to the power 2 is exactly positive 81. So we have positive 1. We have two negative numbers. This is positive. This is positive. You can choose test number between -3 and 1. You plug 0. You plug 0. So what's that? So what is the answer? You can plug 0 into here. Positive or negative? Is it negative? Is it right? You can plug the 0 into x, 0 and 0. The 0 plus 3 is positive. 0 minus 1 is negative. 0 minus 5 is -5. The -5 square is positive. We have only one negative number. Yes, this is like negative. The next one, you can choose the test number between 1 and 5. I can choose 3. So what's that? You can plug 3 into here, 3 into x. You can plug 3 into x. So 3 into x, what's that? Positive or negative? So could you run your answer? Positive or negative? Positive? Is right, positive? You can check. You can plug 3 into here. The 3 plus 3 is positive. 3 minus 1 is positive. 3 minus 5 square is negative. 2 square is positive 4. Yeah, all positive. Yes, like this. You can choose last test number is greater than 5. I can choose 6. You can plug 6 into x. So what's that? Positive or negative? Could you run your answer on the chatting board? Positive or negative? Okay. Answer is, yep. Thank you. Thank you for your answerings. Thank you for your answers. So plug 6 into x here. 6 plus 3 is positive. 6 minus 1 is positive. 6 minus 5 is positive. Yes, this is positive. So, what is the answer? The answer is like this one. The graph of f is increasing. Wait a minute. Here is here. You can draw. Graph is better. Was it like graph of f of x? Positive one has increasing. Negative one has decreasing. Positive one increasing. Positive one increasing. So we have this answer. Was it like f of x? F is increasing. On the first interval, negative infinity to minus 3. Negative infinity to minus 3. Another one, 1, 5. Last one, 5 to infinity. The next one, increasing. Was it like the function f is decreasing? Decreasing on only one interval, minus 3, 1. So we have local maximum, local minimum. The local maximum at x. What is x value? Do we have a local maximum? What is x value? Could you run your answer on the chatting board? What's the x value? The local maximum at, what is x? So what is the x value? Could you write your answer on the chatting board? Here, what's graph? Graph is increasing and decreasing. Increasing and decreasing. We have local maximum at -3. We have a local minimum. What's that? Here, graph is decreasing, increasing at 1. Local minimum. Yes. That's it. This is the whole idea for solving this problem. The next we have this one, like this. This one. The next definition, the graph of f lies above all of its tangents on an interval I, then it is called concave upward on I. If the graph of f lies below all of its tangents on an interval I, then it is called concave downward. Concave downward. So this is like a concave upward things. So what's that? So we have this kind of things. Graph is like this. You can choose any point, draw tangent line. Tangent line. You can choose x value. The one function value on the tangent line is a function value f of x. What does it mean? The graph of f lies above this one. Wait a minute. Here, the above the tangent line. So this is concave upward, right? The graph is above x-axis, above its tangent line. So this is concave upward. So one more, concave downward. Graph is like this. Concave downward. What's that? You can choose any point, draw tangent line. The graph of f of x lies below all of its tangent line. Below all of its tangent line, concave downward. Here, this is what? Concave up. This is concave down. One more. You can choose this point. This is slope tangent line like this. This point, slope tangent line. This is slope tangent line. What happens? X value is increasing. What happens? Slope of tangent line. Here, -1, 0, 1, 2. What does it mean? Here, the slope of tangent line is increasing. We have this result. Here, you can just point slope is 1. To this point, slope is 0. To this point, slope is -1. This point, slope is like -2. What does it mean? F prime of x is decreasing. We have one good result. Another one. Do you remember increasing, decreasing test? What's increasing, decreasing test here? F prime is positive. The graph of f is increasing. F prime is less than 0. The graph of f is decreasing. So let me see. I'm going to take one more derivative here. The second derivative positive, the first derivative increasing. So we have this result. The second derivative positive, the first derivative increasing, the function f is concave. The second one, the second derivative is less than 0. The first derivative decreasing here. The second derivative less than 0. The graph of f is So f prime is decreasing, graph of f is concave down. So we have the one good result for checking if the graph of f is concave up or down. How can you do that? Second derivative. Second derivative positive, concave up. Second derivative is like negative, concave down. This is like one good way for checking concavity. This is my explanation like this. Here, second derivative positive, the graph of f is concave upward on I. If the second derivative is less than 0 for all x in I, then the graph of f is concave downward on I. So one more definition, inflection point. A point P on a curve y equals f of x is called an inflection point. If f is continuous there and curve changes from concave upward to concave downward, or from concave downward to concave upward at P, that we call inflection point. What does it mean? Concavity change. Concavity change. This is one good thing. Here, this is concave down. Here, concave down. This one, concave up. This one, concave down. This one, concave up. This one, concave up. This one is concave down. So, do we have an inflection point? Do you know that inflection point? Is it right? How many inflection points do we have from this graph? Do you know that? How many inflection points do we have? Could you check? Three inflection points. 3. We have 4. So 4 inflection point here. B, what happens? Continuous. Concave up to down. So down to up. Concave change it at B. What is C? Concave up to down at C. What is D? Concave up to down to up. Concave down to up here. This one, concave up to up. No, not an inflection point. This is not an inflection point. Concavity doesn't change it. Concave doesn't change it. Last one, P. Concave up to down. Concavity change it. We have the 4 intersection points here. The 4 inflection points. 4 inflection points. So one more. What happens the second derivative at B? You can just check second derivative. In this case is 0. In this case is 0. Was it like P? 0. Was it D? Here we have corner second derivative does not exist. This is like one good property from the inflection point. Right? At inflection point, we have 2 kind of possibilities. Second derivative equal to 0 or second derivative does not exist. So one more. What happens? What is second derivative? Concave up, downward, negative. Upward, positive. Downward, negative. Upward, positive. Upward, positive, negative. What does it mean? The second derivative, sign of second derivative changed from negative to positive inflection point. The positive to negative inflection point. Negative to positive inflection point. Positive doesn't change, not an inflection point. The positive negative, yes, inflection point. This is like whole idea for finding inflection point. This is like algebraic method for finding inflection point. What's that? Step 1. You can find the C values such that second derivative equal to 0 or does not exist. Step 2. The second derivative changes from positive to negative SC or from negative to positive SC. Step 3. You can check function f is continuous or not. Function f is continuous at A. The c f of c is an inflection point of f. That's it. This is the whole idea. You got it? So let me see. So what does it mean? I'm going to give the very simple examples here. F of x equals, we have x cubed. X cubed. So let me see. F prime of x is 3x squared. The second derivative of x is 6x. So step 1, you solve. Second derivative equal to 0, what does not exist? Step 1. Second derivative equal to 0 or does not exist. The 6x is always well defined. You don't need it. Only solve here. 6x equal to 0. X is 0. That's right. So you have to draw real line plus 0. We have minus infinite and 0, 0 to infinity. You can check second derivative. What's that? To this point, minus 1. You plug minus 1 into here. Second derivative. 6 times minus 1 is negative. You can choose 1 into x. 6 times 1 is positive. What's like a graph of f? Here. Concave down. Here, positive is concave up. What's like a 0? So what's like a graph of x cubed? The graph of x cubed is like this. So we have continuous at 0, right? You can plug 0 into function f. 0 cube is well defined. So well defined. So what does it mean? So function f is continuous at 0. So what's that? The 0, 0. This point is inflection point. Inflection point. Right? So like this. So one more example. So one more example is this one. F of x equals 1 over x cubed. The 1 over x cubed. Sorry, 1 over x. Sorry about that. 1 over x. The 1 over x. F prime of x is negative 1 over x squared. The second derivative at x is like 2 over x cubed. So we have it. So we can just solve. Step 1. The first derivative equal to 0. What does not exist? Second derivative equal to 0. Impossible. This is we don't have 0 values. The second derivative does not exist. Does not exist. This is possible. Exactly. The denominator equal to 0. X cube equal to 0. You can draw real line plus 0. You can check second derivative. You choose minus 1 into here. The second derivative is negative. You choose 1 here, plug here. 2 over 1 is positive. What does it mean? The graph of f is concave down, concave up. Concavity changes. So my question is, do we have an inflection point of this graph? Yes or no? Could you run your answer? The concavity changed at 0, right? Down to up. Concavity changed. Sign changed. Negative 2 positives, right? Sign changed. So do we have an inflection point for f of x equals to 1 of x? Yes, yes, yes. Unfortunately, no. Why? What's step 3? Continuous or not. Always check. How can you check continuity? You can plug 0 into original function. So f of 0, what's that? 1 over 0 is undefined. Function value is undefined. What does it mean? Function f is not continuous. Not continuous. at 0. So what does it mean? We don't have an inflection point. We don't have inflection point. So we don't have inflection point. So really be careful. So always check what? Third step. The third step. We can just sketch the graph is very clear. The 1 of x is this one. The like this. Concave down, concave up, concave changed at 0, but not continuous. So we don't have an inflection point. Really be careful for solving this kind of problem. How can you find the inflection point? Concavity changed. One more. The graph is well connected. The function value exists. The function f is continuous S. The next, so we think about second derivative test. Suppose the second derivative is continuous at C. The f prime of C equal to 0. Second derivative is greater than 0. What happens? F has local minimum. Second one, f prime of C equal to 0. The second derivative of f at C is less than 0. Then f has a local maximum at C. This is like make sense or not. I can draw the graph. This is very clear. So we have graph is like this. We have C. What's that? We have horizontal tangent line. First derivative is 0. It's good. It's like a local minimum. What is the second derivative? So this graph is concave up. What does it mean? Second derivative SC is greater than 0. Yes, true. The next one, graph is like this. Like this. You can choose C. You can draw horizontal tangent line SC. The first derivative SC is, yes, equal to 0. One more. This graph is concave down. What does it mean the concave down? The second derivative SC is less than 0. Concave down, less than 0. Yes, we have local maximum. So we call the second derivative test. So like this, second derivative test. That's good. The next, I'm going to give one example. Suppose that the second derivative f of x equals x plus 3 square, x minus 3, x minus 7 cube. So how can you solve? We always use interval of concavity and the inflection point. Here, you can solve either one. Second derivative equal to 0 or second derivative does not exist. You solve this one first. Second derivative is a polynomial, always well defined. You don't need. So here, only second derivative equal to 0, only this one equal to 0. And 0, you solve x equals negative 3, 3, and 7. The next here, we can draw real line, you plot. Negative 3, 3, and 7. You can plot these points. So next here, you can check the second derivative of x is positive or negative. So how can you do that? You can choose test number. So here, the first interval is minus infinity to negative 3. Second interval, negative 3 to 3. The third interval is 3 to 7. The last one is 7 to infinity. We have 4 intervals. You can choose test number. You choose minus 4. You plug minus 4 into x here, second derivative. Negative 4 plus 3 square is minus 1 square. The 2 is like even power, always positive. The minus 4 minus 3 is negative. Negative 4 minus 7 is negative 11 cubed. The 3 is like odd power. This is also negative. So negative times negative is positive. You can choose 0. Right? You can plug 0 into x. You can plug 0 into x. 0 plus 3 positive, 0 minus 3 is negative, 0 minus 7 is also negative, negative times negative is positive. You can choose like 5, you plug into x. Here, plug 5, 5, 5. So what's that? 5 plus 3 is positive, 5 minus 3 is positive, 5 minus 7 is negative. We have only one negative, this is like a negative. The last one, you choose 8. Choose 8. You plug 8 into x. 8, 8, so 8. 8 plus 3 positive, 8 minus 3 is positive, 8 minus 7 is also positive, all positive numbers, positive. What's the graph of f? Positive second derivative has concave up, positive, concave up, concave down, concave up. So what is the answer? The graph of f is concave up on 3 intervals, minus infinity minus 3, and negative 3 to 3, and last one, 7 to 8, 7 to infinity. The graph of f is concave downward. What's that? Only one negative sign, 3 to 7. So next, how many inflection points do we have? How many inflection points do we have? We have 2. So let me see. The graph of f is continuous. Continuous? Yes, continuous. Second derivative is polynomial. You can find the antiderivative. Like first one is like also first derivative is also polynomial. The original function f is also polynomial. Always continuous. We have sign change it 2 times. The positive to negative at 3. The negative to positive at 7. So we have 2 inflection points. Inflection points. What's that? Here, x component 3, y component, we don't have a function f, only write like this, 3 and f of 3. Another one, 7. X value 7, y value is f of 7. So that's it. We have 2 inflection points. It's like whole idea. The next one. Suppose that here, I already explained everything. This one, the same, like this. The next example, f of x equals x to the 4, negative 6x squared plus 10 is given. Find the intervals of f on which f is increasing. Second one, find the intervals on which f is decreasing. Third one, find the local maximum, local minimum. The first one is find the intervals on which the graph of f is concave up, concave down is 5. 6, find all inflection points of f. Seventh one, sketch the graph of f. So how can solve this kind of problems? I will explain this one on another like whiteboard. I can use whiteboard here. The whiteboard is here. I can use whiteboard. This one. Like this. here. So let me see. What is like a given function? Here. So f of x is here. F of x is the x to the 4 minus 6x squared plus 10. This one. So I want to check graph is increasing or decreasing first. How can you do that? You can take first derivative. The x to the 4 prime is 4x cubed. X squared prime is 2x. 2 times negative 6 is negative 12x. The 10 prime equal to 0. The next factor of 4x. We have x squared negative 3. The next, you need to find like a critical number. The first derivative equal to 0, or the first derivative does not exist. The f prime of x is the 4x cubed negative 12x like a polynomial. Polynomial is always well defined, but we don't have it. Only solve here, this one. The 4x times x squared negative 3 equal to 0. From the first one, x equal to 0. From the second one, x squared equal to 3. 3. So what is x? X is 0 and the x squared equal to 3. What is x? So could you run your answer? X squared equal to 3. What is x? The square root of 3 is right. Square root of 3 is right. Only square root of 3. The what's power? Power is even power. What does it mean? The square root of 3 and negative square root of 3. We have these numbers, right? So like this. The next, you can draw real line. You can plot here minus root 3. Here 0. We have root 3. We have 4 intervals. Minus infinity to minus root 3. The minus root 3, 0. 0 root 3. The root 3 to infinity. So you can choose test number. Here, you can check f prime is a positive or negative. You can choose test number. I can choose negative 2. You can plug a negative 2 into here. The 4 times negative 2 is negative. The negative 2 squared is 4. 4 minus 3 is positive. We have the negative. I can choose minus 1. You plug into x again. The 4 times minus 1 is negative. So what is this one? The minus 1 squared is positive 1. 1 minus 3 is negative. The negative times negative is positive. You can choose 1. You can plug 1 into here. The 4 times 1 is positive. 1 squared minus 3 is negative 2, negative. Positive times negative is negative. I can choose 2. You can plug 2 into x. 4 times 2 is positive. 2 squared equals 4. 4 minus 3 is positive. So we have positive. What's like a graph? Graph of f is decreasing, increasing, decreasing, increasing. So what is the answer of first and second question? So we know this one. The function f is increasing. On here, which one? This one. The negative root 3 of 0. The negative root 3 to 0. Last one, root 3 to infinity, increasing. The root 3 to infinity. The function f is decreasing. On here, the first interval, minus infinity to negative root 3, the negative infinity and minus root 3, and here, 0 to root 3, like this. Another one, do we have a local maximum, local minimum? Do we have a local minimum? Do we have a local minimum of f? Yes or no? Could you run your answer? Do we have a local minimum? Yeah. So what is it like x? What is x value at which f has local minimum? So what is x value? X value is here minus root 3. Graph is decreasing, increasing, decreasing, increasing, negative 3. We have f of minus root 3. You can calculate. You can plug into original function. Here, so we have the negative root 3 to the power 4. Negative 6 times negative root 3 square plus 10. You can calculate. Was it like negative root 3 to the power 4? The same to negative root 3 squared and squared. The negative root 3 squared is only 3. 3 squared equals 9. Here, this is like 9. So we have 9. 9 minus 3 times 6 is 18. Plus 10. Is right? We have 1. Right? So we have one more local minimum here, decreasing and increasing, and root 3. So we have f of root 3. So root 3 to the power 4, there will be 6 times root 3 square plus 10. We have the same answer. 9 minus 18 plus 10 equals 1. So what does it mean? This is local maximum. Sorry, minimum. Local minimum. This is also local minimum. So one more. We have local maximum at 0. Graph is what? Increasing and decreasing. Graph is increasing, decreasing here. We have local maximum at 0. You calculate f of 0. F of 0 is exactly 0 to the power 4, negative 6 times 0 square plus 10. We have 10. This is local maximum. Local maximum. This is like number 1, number 2, number 3. You can just solve 4, 5, 6. Concave up, concave down, and the inflection point. How can you solve this problem? I erase it here. We can use second derivative. Is right? You can calculate second derivative. The second derivative is the first derivative is given. The first derivative is 4x cubed negative 12x, exactly. The 4x cubed negative 12x prime. The 4x cubed prime is 12x squared. The negative 12x prime is negative 12. The negative 12 is common factor, factor out. You can do factor out one more, x minus 1 times x plus 1, like this. So you can just solve the second derivative equal to 0, or second derivative does not exist. The second derivative is polynomial. So we don't have any answer of this case. Only first case. The negative 12 x minus 1 times x plus 1 equal to 0. So what's x? X minus 1 equal to 0, 1. X plus 1 equal to 0, minus 1. We have two numbers. Next, you can draw the line. You can choose 1 and minus 1. We have 3 intervals. So, sorry, minus 1 here, this is positive. Minus infinity to minus 1. So 1 to 1. Here, we have 1 to infinity. So next, you can check. Second derivative is positive or negative. You can think about second derivative. Here, the second derivative is positive or negative. You can choose test number. You choose negative 2. You plug negative 2 into here. The negative 12 is always negative. The negative 2 minus 1 is negative. Negative 2 plus 1 is like negative. We have 3 negative numbers. So this is, sorry, this is a positive. This is my typo. Sorry about that. It's a positive. Sorry. This is my typo, the positive. So we have positive. You can choose 0. You plug 0 into here. The 0 minus 1 is negative. 0 plus 1 is positive. So this is negative. You can choose 2. You plug into x. 2 minus 1 is positive. 2 plus 1 is positive. This is a positive. What's the graph of f? Graph of f is like concave up, concave down, concave up. So what is the answer? Answer is like this. The graph of f. The graph of f is concave up on 2 intervals. Here, minus infinity to minus 1, 1 to infinity. So we have the negative infinity to minus 1 and 1 to infinity. The graph of f is concave down on only middle interval, the minus 1 to 1 here. Sorry, this is minus 1 to 1. So that's it. The 6th problem, inflection point. Do we have inflection points? So do we have inflection points? So how many inflection points do we have? Could you write your answer on the chatting board? So how many inflection points do we have? Yep, we have the 2 inflection points, right? We have 2 inflection points. What's that? Concave up to down at minus 1, down to up and 1. One more. The function f is polynomial, always continuous. It's good. We have 2 inflection points. You can calculate f of minus 1. You plug minus 1 into original function. Minus 1 to 4. Negative 6 times minus 1 square plus 10. Calculate. 1 minus 6 plus 10 is 5. So another one, f of 1. So 1 to 4, negative 6 times 1 square plus 10. This is also 5. So what's like inflection point? We have 2 inflection points. The inflection points. Inflection points. What's like inflection points? The first one, x component to minus 1, y component to 5. The second inflection point is x component to 1, y component to 5. So we have 2 inflection points. It's like a whole idea. The next two, you have to sketch the graph. How can you sketch the graph f of x? You can combine this whole result. So what does it mean? So like this. You can plot the inflection points, the minus 1, 5. Here we have the minus 1 and 5. Inflection point, the 1 and 5. Inflection point. You can plot local minimum. Local minimum is the negative root 3 and 1. Here, the negative root 3 and 1. So we have this point. So we have the positive root 3 and 1, the local minimum, the positive root 3 and 1. This point, we have local maximum 0 and 10, x component to 0, y component to 10 here. you have to connect. What's like a graph? The x is the less than -3, the less than minus root 3. What's like a graph here? Decreasing and concave up. So graph is decreasing, concave up. So like this. The minus root 3 minus 1. Graph is increasing, concave up. Concavity doesn't change. Increasing, concave up, like local minimum, like this. So minus 1 to 0. Minus 1 to 0 is here. Also increasing, minus 1 to 0, concave down. Concavity change, like inflection point. Concavity changes, so like this. The 0 to 1, the 0 to 1 decreasing, 0 to 1 concave down. Concave doesn't change. Decreasing, concave down. 1 to root 3, here 1 to root 3 decreasing. The 1 to root 3 concave up. Graph is like this. Right, this one. So the root 3 to infinity here, increasing, concave up. Increasing, concave up. That's it. This is the graph of f of x. This graph of f of x. It's like the whole idea of sketching the graph. So like this. Okay. So far so good. So far, do you have any question? So if you have any question, always write your question on the chatting board. I will answer your question. Next, so we are going back to slides again. Here, so this is my explanation, exactly same to my previous one, the same, so like this. I don't explain the more. So like this. So you can just sketch the graphic, so we have it. Just like exactly same, so like this. The next one. The sketch a possible graph of f that satisfies the following conditions. So following conditions here. F of 0 equal to 0, f of 2 equal to 3, f of 4 equal to 6, f prime of 0, f prime of 4 equal to 0, f prime of x is positive for x is between 0 and 4. F prime of x is less than 0, x is less than 0, x is greater than 4. The second derivative is positive for x is less than 2. The second derivative is less than 0 for x is greater than 2. How can I sketch the graphic? Just like idea. The idea is like this. The first one here, f prime of 0 equal to 0, f prime of 4 equal to 0. What does it mean? In this case, 0 and 4 are critical numbers. The critical numbers, we know these kind of things, the critical numbers. So next, you can just check the graph is increasing or decreasing here. So we have 0 and 4. F prime of x is positive. What does it mean? The graph of f is increasing or decreasing. What's that? F prime of x is greater than 0. Graph f is increasing or decreasing. Could you run your answer on the chatting board? What's that? Increasing or decreasing? Okay, the graph is, yes, increasing. Yeah, increasing. So thank you. So we have from here, so we can draw real line. So here we have 0 and 4. What's the graph of f? Graph is 0 and 4. The 0 and 4, the middle one, graph is what? Just increasing. Graph is increasing like this. So x is less than 0 and the greater than 4. F prime of x is less than 0. Graph is what? Decreasing and decreasing. We have this kind of things. So next, second derivative is positive. What does it mean? Second derivative positive, concave up or down. What's that? Could you run your answer? Second derivative is greater than 0, concave up or concave down? Concave, yep, up. So here, you can draw another line here. You choose middle one, 2. Graph is x is less than 0, concave up, concave up, concave up. So here, x is less than 0, greater than 0. Second derivative less than 0, concave down, concave down. So like this, right? So next, you can sketch the graphic. How can you sketch the graphic? So this is like the one good way for sketching the graphic. You can draw real line. You can plot given point f of 0 equal to 0. F of 0 equal to 0, we have this point. F of 2 equal to 3. F of 2 equal to 3 is, so 2 has point 3. This point. 4 has 6. So 4 has like 6. We have this point. We can connect these points. The first one, x is less than 0. What's that? Graph is decreasing concave up. Graph is what? Decreasing concave up. Decreasing concave up. Decreasing concave up. So like this. So 0 to 2, concave up and increasing. Concave up, increasing. Concave up, increasing. Here, 2 to 4. Was it like 2 to 4? Graph is increasing, concavely change it. Concave down, like an inflection point. Inflection point, concavity change it. Concavely change it. So 4 to infinity, concave down and decreasing. Graph is decreasing, concave down. So that's it. This is the whole idea for sketching the graph by using this kind of methods, right? This is the idea. So like this. This is like an example, the graph of the derivative f prime, the derivative of f. This is like a typo, sorry. So this is like a typo, so not this one. The derivative f prime. The derivative f prime of a continuous function f is given, right? We'll erase this off. The graph of the derivative f prime of f is given, so like this. The first question. So we can find interval where function f is increasing. You can find the intervals where f is decreasing. Find local maximum at x value. Find x value at which f has a local maximum. Find x values at which f has a local minimum. So you can check the concave up. What's like intervals? So where is f concave up? So where is f concave down? Find inflection point, only x values. So this graph is exactly f prime of x, f prime of x. So how can you solve this kind of things? Here, we think about first 3 problems first, increasing, decreasing, local maximum, local minimum. You can think about this one, concave up, down, inflection point later. So here, how can check increasing, decreasing, local maximum, local minimum? I want to use increasing, decreasing testing. Can you remind? So f prime of x is greater than 0. F of x is increasing. F prime of x is less than 0. F of x is decreasing. So one more note. So f prime of c equal to 0. So f prime of c does not exist. The first one, so sin f prime changes from positive to negative. Positive to negative, like graph is increasing, decreasing. F of c is local maximum. F prime of c changed from the negative to positive. Was like a graph of f decreasing, increasing. We have a local minimum. Local minimum. We can use these whole kind of things. So we just solve like this. Here, increasing on fine interval, decreasing. Interval, we can find local maximum, find x values, the local minimum at x values. The first 4 problems. Just solve like this. So let me see. You can use it. How can you check f is increasing or decreasing? Check f prime of x is positive, increasing. F prime of x is less than 0, decreasing. F prime of x is given, what happens? So below x-axis, decreasing. Above x-axis, increasing. Here, this one is negative. What does it mean? X is the less than 1. F prime of x is below x-axis, negative number. We have decreasing. So we have negative infinity to 1. The 1 to 3 above x-axis positive, increasing. 1 to 3. Here 3 to 5 also positive, increasing. The 5 to 6 below x-axis negative, decreasing. 6 to 7 positive. We have increasing. 7 to 9 here below x-axis negative, decreasing. 7 to 9. 9 to 10 above x-axis increasing. 9. 9 to 10. 10 to 11 also above x-axis positive, increasing. 10 to 11. 11 to infinity below x-axis decreasing. 11 to infinity. So we have it, right? So how can you find local maximum, local minimum? F prime of c equal to 0. What does it mean here? F prime of c equal to 0, 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 F prime c equal to 0, equal to 0. Exactly x-intercept, because graph is f prime of x. F prime c does not exist like vertical asymptote, is right? We don't have a function value. F prime of x does not exist at 6 and 10. You can think about it. This is 1. Local maximum or local minimum. So what is your answer? At 1, local maximum or local minimum. Could you run your answer? 1, local maximum or local minimum. Here, 1, local maximum or local minimum. At 1, what's that? This is not F, so not F, F prime. F prime is like a key. Maximum, maximum. Maximum here is 1. What happens? Sign is what? Negative to positive. Graph is what? Decreasing, increasing, local minimum. Here, what's the graph? This graph of f is, this F prime is a negative. Graph is what? Decreasing. So here, 1 to 2, increasing. Graph is decreasing, increasing, local minimum. Really be careful. This one. What's 3? The local maximum, local minimum, 1, neither. So what is your answer? 3. 3, neither. Yeah, because positive sign doesn't change. It's just increasing, increasing. So nothing. What's 5? What's 5? Maximum? Is right? Maximum? Yes. Positive, increasing, negative, decreasing. Graph is increasing, decreasing at 5. Local maximum at 5. What's 6? What's 6? Yes. This is negative, positive. One more. What's like assumption? Function f is what? Continuous function, well connected. We have a corner. In this case, we have a corner. Here 6, graph is decreasing and decreasing, and increasing. We have a local minimum at 6. 6. What's the graph? Graph is, next one. Graph of f is at this point, decreasing and increasing. We have like a cusp, the local minimum. We have a cusp at 6. What's 7? 7. Local, yes, maximum. Increasing, decreasing is right. Graph is increasing, decreasing. Local maximum at 7. What's 9? Minimum, again, is right. Decreasing, increasing. Graph is decreasing, increasing at 9. Minimum. What's 10? Yeah, neither. Increasing, increasing. Increasing, increasing. Neither. What's 11? Yeah, maximum. Graph is increasing here, decreasing. Graph is increasing, decreasing. Local maximum at 11. Okay, this is the whole idea for finding the maximum, minimum, increasing, decreasing. This is the idea. The next, the last one is concavity. Concave up, concave down, and inflection point. How can you know these kind of things? Here. Note, f prime is increasing, f of x is concave upward. Could you check the previous slides? I explained these kind of things. F prime of x increasing, automatically the graph of f is concave up. F prime of x is decreasing, f is concave down. The notes, the either second derivative equal to 0 or does not exist. Concavity changed at c, f is continuous at c, that satisfies the 3 conditions. The c and f of c is inflection point. So we can check here, concave up. Concave up, find the interval, concave down. Next one, inflection points. At x. So concave up and down, how can you do that? F prime is increasing, concave down. F prime is decreasing, concave down. Here, this is F prime. F prime is increasing, is right from here to here, like increasing minus 1 to 2. So increasing, concave up. So here, the negative, infinite, and 2. The 2 to 3, graph is decreasing. F prime is decreasing, concave down. The 3 to 4, increasing again, concave up. The 4 to 5 and 6, keep going. 4 to 6, decreasing, concave down. So like this. What is 6 to 8? What is 6 to 8? Concave up or down? 6 to 8. What do you think? 6 to 8. Concave up or down? 6 to 8. Concave up? 6 to 8. So let me see. This is f prime, not f. Only check what? F prime of x is increasing or decreasing. So what's that? 6 to 8. F prime of x is decreasing or increasing? This is f prime. Decreasing or increasing? Graph is what? Decreasing. Is right? Really, because not concave up. This is f prime. Decreasing. Decreasing. What does it mean? Concave down. 6 to 8. What is 8 to 10? Concave up or down? 8 to 10. Concave? Yes. Graph is increasing. F prime is increasing. Concave up. Concave up. 8 to 10. The 10 to infinity. Graph is what? Just decreasing. Just decreasing. So just decreasing. We have 10 to infinity. Concave down. So let me see. How can you find the inflection point? Check what? Second derivative equal to 0. What does not exist? This is first derivative. What is second derivative equal to 0? the horizontal tangent line. 2, horizontal tangent line. 3, the horizontal tangent line. 4. So 6, vertical line, second derivative does not exist. 8, yes, we have this one. 0. So 10, the second derivative does not exist. So here, 2, inflection point. 2, inflection point 1. What do you think? Yes or no? 2. Inflection point? Yes. How can you know that? Here. Graph increasing, what does it mean? This is concave up. Decreasing, concave down. Concavity change that to one more. The function f is continuous from the assumption. That satisfies the both of them. So yes. What's 3? Inflection points? 3? Is yes? Yeah. Here, concave down, decreasing, increasing, concave up. Concave change at 3. Yes. What's 4? Yes. Inflection point? Yes. Increasing, concave up, decreasing, concave down. Concavity changed up to down at 4. It's good. What's 6? What's 6? No, because here, decreasing, concave down, decreasing again, concave down. Concavity doesn't change. Concavity doesn't change at 6. What's 8? This is concave up, concave down to up. Concavity changed at 8. You're right. What's 10? Inflection point 1. What's 10? What do you think? No? No? You know? No? So let me see. Graph is what? Increasing. What's that? Concave up. Here, graph is increasing or decreasing? 10 to infinity. Graph is increasing, decreasing. 10 to infinity. Decreasing. Decreasing is what? Concave down. Concave up. Here, decreasing. Concave down. Yes. Concavity changes from the assumption. Function f is continuous from the assumption. Yes. 10. We have inflection points. So you got it? So this is whole idea for solving this kind of problems. So like this. Okay, so this is all for today's lecture. So thank you for attending my classes. Thank you for answering my questions. I appreciate. So if you have any trouble in any question, write your answer on the chatting board. If you don't have any question, so you can leave a live session. But thank you. You're welcome. So there's no problem. Yeah, you're welcome. Yeah, appreciate. Okay, thank you.